All right. So 5.1 is about circles and parabolas. What we're going to do in 5.1 and 5.2 is we're going to go through each of the four types of conic sections. So in 5.1, circles and parabolas, and then in 5.2, ellipses and hyperbolas. And then in 5.3, we're going to talk a little bit more about them kind of algebraically and stuff, how to tell them apart from one another and that sort of thing. The goal in these sections is to give you the points in a plane perspective of what each of these conic sections are. Okay, so we've already, in the introduction, we already saw that conic sections are literally planes intersecting cones, right? Three-dimensionally. And we also talked about how algebraically they are polynomials in two variables, but as far as their geometric description in 2 dimensions, we're going to describe them as points in a plane. So let's get to it. A circle is the set of all points in a plane that are equally distant from a point in the plane. The point is called the center, and the distance is called the radius. And then I'll provide a link to this video in the module on Canvas, but it's just a picture of somebody drawing a circle using this definition. Okay. So you could pause the video now and watch this in today's module, which is them drawing a circle using the definition, so that you get some understanding of what the definition is saying. But based on this definition, we can come up with an equation for the circle. Okay, so the circle, or the equation of a circle with radius r centered at hk, is x minus h squared plus y minus k squared equals r squared. And here's a proof of that fact. Okay, so let's say that xy is a point on the circle. Then by the distance formula, the distance r between xy and the center hk is going to be r equals square root, right, distance formula, x minus h squared plus y minus k squared. Squaring both sides of this equation yields the result, right? It yields the desired formula. So there you go, right? That's how we know that this is the equation of a circle. So let's practice graphing some of these things, right? So looking at number 1, remember the format is x minus h and y minus k when the center is hk. So what that means is if you want to figure out the center of the circle, you need to change the sign of these numbers. And then this number on the other side, you need to take the square root, and that's going to be your radius, right, or your distance. So here we can see clearly the center is going to be 3, negative 1, and that the radius is going to be 4. So the center is 3, negative 1, right? The center is 3, negative 1, and the radius is 4. So 1, 2, 3, negative 1. There's the center. And then the radius is 4. So from the center, I'm going to go up 4, right 4, down 4, and left 4. And these outer points are the edge of the circle. I'm sure you can do a better job drawing a circle than I can. But there you go. Okay, that's how circles work. On part B, the center would be, now this is a little tricky, but x squared is the same thing as saying x minus 0 squared, right? So the center is 0, 2, 0, 2, and the radius is square root of 5, right? So the center is 0, 2, and the radius is the square root of 5. Square root of 5 is a little bit more than 2. I'm not exactly sure. Let me see. It's a little bit more than 2. Square root of 5. 2.24, so we'll say it's about 2.2. So from the center, I'm going to go up 2.2, 1, 2.2, right 2.2, down 2.2, and left 2.2. And there you go. There's that circle. Try to make it a little better. Anyway, so that's how that works. So circles are really a piece of cake. There's really not much to them. One thing that I will say is that we can solve a circular equation for x. For example, let's say that we have the circle x squared plus y squared equals 9. This would be a circle centered at 0, 0 with radius 3. If we solved this for x, we would subtract the y squared and then take the square root. We would get x equals plus or minus square root 9 minus y squared. So note that if we only took the positive square root, that would only be half of the circle. In other words, x equals square root 9 minus y squared is a semicircle. In fact, x equals square root 9 minus y squared is the right half of the circle with radius 3 centered at 0, 0. And you're welcome to check that yourself in Desmos. Okay, but if you have x equals square root 9 minus y squared, that's the right half. Okay, the left half would be negative square root. It would be x equals negative square root of r squared minus y squared. And then the upper and lower halves would be what happens when you solve for y, right? So if you solve for y instead of solving for x, and you take the positive square root, then you get the upper half. If you take the negative square root, then you get the lower half. So let's practice graphing some semicircles. Here I've got a semicircle. It's an x equals blah, so that tells me it opens left or right. And then the negative sign out here tells me that it's the left half. This is the left half of the semicircle. So it's the left half of the semicircle centered at 0, 0 with radius 4. Right? Radius 4. So it's centered at 0, 0, radius 4, but it's only the left half, so I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so it's just this semicircle. Okay, this one would be the upper half of the circle centered at 0, 0 with radius 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 gives us the upper half of our circle. Okay, so that's what those would look like. We can go backwards, of course. Given some information about some curves, we can write the equation for them. So for example, let's write the equation for a circle with radius 8 centered at negative 1, 7. So if it's centered at negative 1, 7, then it's going to look like x plus 1 squared plus y minus 7 squared. Okay, so that's going to give you center negative 1, 7. And if the radius is 8, then this should be equal to 8 squared, which is 64. Okay, so that's how that works. Part B asks us for the lower half of a circle with radius 5 centered at 0, 0. Now I have a hard time doing this in my head all at once, so what I'm going to do actually is find the equation for the circle, and then I'll find the lower half by solving for y and taking the negative square root. So the equation for the circle would be, well, if it has center 0, 0, then the equation for the circle would be x minus 0 squared plus y minus 0 squared equals r squared, 5 squared, right, 25. But if I only want the lower half, then I need to solve for y. And then I need to take the negative square root. So I'm going to get y equals negative, right? Because I want the lower half. So I take the negative square root, 25 minus y minus x squared. So there's the semicircle, the lower half of a circle centered at 0, 0 with radius 5. I can do a similar thing for part C. The right half of a circle with radius 3 centered at 2, negative 5. So the equation of the full circle is going to be x minus 2 squared plus y plus 5 squared, right? 2, negative 5, sorry, with radius 3, so this equals 3 squared, 9. But now I want the right half of this circle, so I'm going to solve for x. Okay, I'm going to solve for x, and I'm going to take the positive square root because I want the right half. So I'm going to say x minus 2 squared equals 9 minus y plus 5 squared. Then I can take the square root. X minus 2 is going to be the positive square root of 9 minus y plus 5 squared. Positive square root because I want the right half. Okay, and then if I wanted to finish solving for x, I could say something like, x equals square root 9 minus y plus 5 squared plus 2. Or I could even expand this, right? Like I could say y plus 5 squared is y squared, 10y, and 25, and I'm just distributing the negative sign as I go. But then, of course, we can combine the 25 and the 9 to get something like 25 minus 9 is 16, right? So we would get negative y squared minus 10y minus 16 plus 2. So, I don't know. Like, this one would be fine. That answer would be fine. This answer would be okay. This answer would be okay. Any of those, right, would do the trick. Okay, so that's how that works. So circles, really not much to them. Parabolas are a little more complicated. So the planar definition of parabolas is as follows. Okay, a parabola is the set of all points in a plane that are equally distant from a line and a point not on the line. So you take any line you like, and then any point that's not on that line, and if you plot all of the points that are equally distant from the line and the point, the shape you're gonna get is a parabola. Okay. The line is called the directrix, and the point is called the focus. So at this point, I would strongly encourage you to pause this video and watch this. Okay. This is gonna, so I'm not starting the video right, so you can see here t equals 237. So I'm not starting right at the beginning of the video. It starts, about 2 minutes in. But you're gonna wanna watch this video because the person in this video draws the parabola based off of this definition, right? So based off of this definition, they draw the parabola so that you can convince yourself that you really do get a parabola if you look at the points that are equally distant from the directrix and the focus, right? You get a parabola shape out of that. So again, I'll post that on Canvas. I'll post a link to this on Canvas, but pause the video now and take a look at that. Okay. Okay. So now that you've watched that, hopefully, let's talk about the equation for a parabola. Okay. So let p be a positive real number. The equation of a parabola with focus 0p, right? So the focus is going to be right on the y-axis, right? It's going to be 0p. And the directrix is going to be y equals negative p, okay? So the equation for a parabola with focus 0p and directrix y equals negative p is y equals x squared over 4p. Or equivalently, you can multiply by 4p and get 4py equals x squared. Okay, so we're going to prove that this formula works. I'm going to need to pause this video real quick. You won't notice though. Okay, so let's prove this thing. So first of all, I want to draw a picture. So let's say that xy is a point on the parabola. Okay, and then let's draw a picture of the parabola with the focus, directrix, and our point xy. So, so the picture is going to look something like this. So here's my coordinate system, and let's say that the focus is up here, 0p. And that means that the directrix is going to be down here. Oh, I should have done a little better job, but the directrix is going to be down here at y equals negative p. So this distance and this distance needs to be approximately the same, right? So y equals negative p is down here. And this is the point 0p. Okay. So we want to draw the points that are equally distant from the focus and the directrix. So for one thing, I know that from here to here is p units, and from here to here is p units. That means the point 0, 0 has got to be on my parabola, right? And the rest of the points are going to be, they're going to be parabolic. Right? They're going to be parabolic in nature. So it's going to look kind of like this. This is our parabola. So now let's take a random point on this parabola, like say maybe this one right here. Okay, so we'll call this point x, y. So according to the definition, of what a parabola is. It's the set of all points that are equally distant from the focus and the directrix. So in other words, if I look at this distance here, right, from the focus to the point on the parabola, and if I look at this distance here, or I should have drawn it straight down, forgive me. So if I look at this distance here, forget about this thing. So if I look at this distance here, from this point down to the directrix, these two distances should be the same. And they don't look the same because of the way that I've drawn the picture, because I didn't draw it very well. But according to the definition, right, these two distances should be the same. This is the point. This would have the same x coordinate as our point xy, so it would be the point x negative p. All right, so that's that point down there, x negative p. Okay, now by definition, the distance from xy to the focus is the same as the distance from xy to the directrix. So let's see if we can write some expressions for what those distances are. The distance from xy to the focus is it would be x minus 0 squared, right, just using the distance formula, plus y minus p squared. So that's that one. The distance from xy to the directrix is the length of this line segment. So the distance from xy to the directrix is going to be x square root of x minus x squared plus y minus negative p squared. Or in other words, this would be the square root of, well, x minus x is 0, and this is y plus p squared. Okay, now since these two distances must be the same, right, we see then that, oh, by the way, right, x minus 0 is just x, so this is just square root of x squared plus y minus p squared. Okay, so since these two distances are the same, we must have that square root of x squared plus y minus p squared equals square root of y plus p squared. And if that's true, then we can take the square both sides to get x squared plus y minus p squared equals y plus p squared. And then we can do some algebra, and we end up with the equation that we wanted. Okay? So this is the equation for a parabola with focus 0p and directrix y equals negative p. Now, a couple things to say about that. So, at first glance, y equals x squared over 4p doesn't look a whole lot like the parabolas we're used to seeing, right? The parabolas that we've graphed in this class and that you probably graphed in your previous algebra classes, they all looked like, y equals, x minus h squared plus k or something like that, right? This doesn't look anything like that. But note that when p equals 1/4, right? 4 times 1/4 is 1. X squared over 1 is just x squared. So when p equals 1/4, we get the standard parabola y equals x squared. Okay, so it is. It's just a parabola. The vertex of this parabola is 0, 0. Now, if the vertex were located at hk, then the equation would become y equals x minus h squared plus k, like I just wrote down. Okay. For the sake of consistency, we're going to rewrite this equation as y minus k equals x minus h squared in this section. And you'll see y below, but suffice it to say that this way, if you write it this way, then it's a lot like the circle, right? Where the circle was centered at hk, and you change the signs of both of them. You're going to do the same thing here, right? Only instead of being the center, this is going to be the vertex, right? The vertex of the parabola is at hk. So you change the sign of both. When you write it this way, it sometimes gets a little confusing because you're never sure, like, should I change the sign? Should I not change the sign? But this way, you know that you always change the sign. Okay. Now, another thing to point out is that in the case above, the directrix is the horizontal line y equals negative b. In fact, the directrix could be any line. In particular, it could be a vertical line. If the directrix is vertical, then the parabola would open left or right instead of opening up or down. And it's left as an exercise to you, the reader, to prove that the equation of a parabola with focus P0 and directrix x equals negative b is 4px equals y squared. You can do that. There's an exercise in the homework that asks you to prove that. Just follow along with the proof that we did on the previous page. Okay, and you should be fine. Okay. So in general, here's how I think about parabolas, because usually this is the way that you're actually going to see them, is in one of these two formats. So if your y group leads, right? So if you have y equals x squared, right? Basically, like if you strip all the other stuff away, this is a y equals x squared. So if you have y equals x squared, then that's going to be a parabola that either opens up or down. Okay? Because y is leading, it's going to either open up or down. It's going to open along the y-axis. Okay. You can tell if it opens up if a is a positive number. It opens down if a is a negative number. Okay. But then the vertex is hk. Okay. If you have something where x leads, then that's going to be a parabola that opens left or right. It opens right if a is positive and left if a is negative. And again, the vertex is hk. All right? So notice that h is always the number that's with x. Okay? So the x coordinate of your vertex is always the number that's attached to x. The y coordinate of your vertex is always the number that's attached to y. Okay? You change the sign of both of them. Okay? But that's how that works. Okay, so I think I've said all of this already. Let's just do some examples. So graph the following parabolas. Here we have y equals negative x plus 2 squared. Since y leads, this parabola is going to open up along the y-axis. It's going to open up or down. Since it's negative, it's going to open down. The vertex is the point negative 2, right? X coordinate goes with x, so negative 2, 0. It looks like negative 2, 0. So negative 2, 0. And then this parabola opens downward. Now this is just a quadratic relation, just like any quadratic relations we've seen so far. So if it opens downwards, I know that I'm going to go, usually I would go over 1, up 1, over 2, up 2. But I'm going to go over 1, down 1 since it's opening down, over 2, down 4. 1, 2, 3, 4. Okay, same thing in the other direction. If I wanted, I could go over 3, down 9, 4, 6, 7, 8, 9 to get the next 2 points. But that's what my parabola is going to look like. Okay, we've been graphing these things all during the entire course so far, right? Let's do something like part B. Now this one is new. This one is x plus 4 equals y minus 3 squared. So since x is leading, this is going to be a parabola that opens up along the x-axis. So it's either going to open right or it's going to open left. Well, since a is positive, this thing is going to open right. Now the vertex is going to be the point negative 4, right? The x coordinate of my vertex goes with x. I changed the sign though, so negative 4, positive 3. So the vertex is negative 4, positive 3. And then this opens up to the right. So imagine that you're graphing a parabola, but it's just tipped over. So instead of going over 1, up 1, over 1, up 1, we're going to go over 1, up 1, right? Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 2, up 4. Over 3, up 9. 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16. So that's off the charts. We can't go to the next one, but that's what that one looks like. Okay. Okay, let's look at part C. We've got y equals x plus 3 squared plus 1. Right off the bat, I noticed that this is not in the format that that we talked about on the previous page. I need to move this 1 over to the other side so that I have y minus 1 equals x plus 3 squared. Okay. Now, because the y group leads, this thing is going to open up or down. It's actually going to open up since A is positive. All right, and the vertex here is the point -3, 1. Okay, and this one opens up. Four, 5, 6, 7, 8, 9. And there we go. One more. X minus 1 equals -y squared. Because I have x equals y squared, this one is going to open left or right. It's going to open left because this is negative. So it opens left, and the vertex is 1, 0. 1, 0. And then it opens left. Okay? Okay. So there's that. There's that one. So that's how parabolas work. Now, we could talk about semi-parabolas the same way that we talked about semicircles, right? But there's really no need to do this because a semi-parabola is something that we've already seen. It's just a square root function, right? For example, solving x plus 4 equals y minus 3 squared, this one that we did part B, right? So this one right here. Solving this for y, we would get we would take the square root, we would get y equals plus or minus square root of x plus 4 plus 3, right? That's just square root function that we know how to graph, okay? So no need to talk about semi-parabolas, they're just square root functions. Now while we're on the subject though, it's worth pointing out that going back to semicircles, right? Y equals 25 minus x squared is a semicircle. Y equals square root 25 minus x is not a semicircle. This is just a square root function. Okay, so be careful with that, right? There's a very small difference, but this one is basically a semi-parabola, and this one is a semicircle. Okay. Very good. So that's all I have to say about circles and parabolas for now. See you in the next section.